Hi everyone, I am Dr.D.Princy, Assistant Professor, Department of Computer Science, Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. In this video, I am going to explain the concept of finite automata. In general, finite automata is a mathematical model. It is a theoretical model which is used for a computation. That model recognizes the patterns in a string over a set of alphabets. It also used to make decisions at each step with limited memory. It includes finite states, input alphabets, and transition function. Finite state is nothing but a set which contains finite number of states. Input alphabet is a set which includes the input symbol. Transition function is a function which is used to move from current state to another state based on the current state and the input symbol. Generally, finite automata is divided into two categories. One is deterministic finite automata. The second one is non-deterministic finite automata, shortly known as DFA and NFA. DFA, exactly one transition per symbol per state. It does not have any ambiguity in execution path. It is very simpler to implement, and also more states may be needed when we compare to NFA. Non-deterministic finite automata, multiple or zero transition allowed per symbol. We can guess the correct path. That means there are many paths. Epsilon transitions over empty string moves allowed here. Theoretically, NFA is equivalent to a DFA. The formal definition of DFA. A DFA is a 5-tuple set which includes Q, sigma, delta, Q0 and F. Capital Q is the set of states which is finite number. Sigma is an input alphabet symbol which is also finite set of input symbol. Delta is a transition function which take current state and the input symbol that maps to the next state. Q0 is the initial state or the start state where the computation begins. Capital F is the accept states. It is a subset of Q. When we presenting the DFA, we can use either transition diagram or transition table. Transition diagram is a directed graph. In it, each node represents a state. Each arc represents a transition which is labeled with an input symbol. The start state has an incoming arrow. Accepting states are shown with the double circle. The remaining normal node enclosed or shown with single circle. Transition table, it is a table in which row represents states, column represents input symbols. The entries are the next state, start state marked with arrow, right arrow, and the accepting states marked with asterisk. So this is the state transition diagram. For a simple example, this is a graphical notation where states are circles and transitions are labeled arrows. Q0 is the start state which have an incoming arrow. When it reaches 0, the states remaining in the same state Q0. When it reads 1, it goes to the Q1. Q1 is the accepting state, so it is shown with double circle. When it reads once again, it goes, looped with the same states. Regular states denoted as a single circle, accept state or final state denoted with double circle, start state arrow using right arrow, transition transition labels labeled on the arrows. When the transition moves to the same state, the self looping is used. Transition table is another notation to represent the DFA. The row represents the states. Here two rows, start states and the accept state. Start states using the right arrow and accepted state or final state using asterisk. And column represents the input symbol. 0 and 1. When Q0 takes 0, it remains in the same state. When Q0 takes 1, it goes to the Q1 state. When Q1 reads 0, it goes back to the Q0 state. When Q1 reads 1, it remains in the same state. Thank you all.